okay, and our a0 is clearly defined. A0 is equal to 7. Okay? So using our solution, we end up with the nth term. Okay, so the general solution. So the general solution becomes an must be equal to b to the n. So it's 4 raised to the power of n times a0, which is 7, plus c, which is 0, times 1 minus b, and b is 4 to the n, okay, divided by 1 minus b, which is 1 minus 4. And just keep in mind, 0 times anything, it just falls away. So we end up with here, an is equal to 4 to the n times 7. Okay? We can simplify this because this is the same as an is equal to 2 squared raised to the power of n times 7, which gives us the nth term is simply equal to, when we have an exponential, we have a number raised to a power again, exponentiated again. It's the same as the base raised to the power. The new power is the product of the exponent, so this becomes 2 to the power of 2n times 7, which is, if I rewrite this as 7 times 2 to the power of 2n. So in this situation here, you can see that what we've ended up with is we've ended up with a closed form solution. Okay, the nth term in terms of, there's no previous terms here. All that's the only variable here is n, is the term that we're actually looking for. Okay? We could have done these solutions a different way. We could have done them without using this particular general solution that we developed in our previous video. We could have just iterated out these things. So let's say using iteration, okay, we have, okay, so let's just keep in mind here that, once again, taking this example here, we have an is equal to 4 times an to the minus 1, and a0 is equal to 7. So using iteration, and let's just iterate the terms, so we have a0 is equal to 7. We have a1 must be equal to 4 times a0, which is equal to 4 times 7. We have a2 must be equal to 4 times a1, which is equal to 4 times 7. Okay. We have a3 must be equal to 4 times a2, which is 4 times the previous, which is 4 times 7. Okay. We can actually see, hopefully, what's happening here is that the term at index 1 is simply equal to 4 to the power of 1 times 7. The term at index 2 is, well, 4 times 4 is going to be 4 squared times 7. The term at index 3 is 4 times 4 times 4 is 4 cubed times 7. So, I mean, we could deduce from that the nth term, a to the n, is going to be equal to 4 times a to the n minus 1, okay, which is the same as 4 times, well, in relation to a to the n minus 1, it's going to be 4 times 4 to the n minus 1 times 7, okay, which gives us a solution that an is simply equal to, well, 4 times 4 to the n minus 1 is the same as 4 to the power of n minus 1 plus 1, which is the same as 4 to the power of n times 7, which gives us an is equal to 7 times 4 to the n. And 4 to the n is the same as 2 squared, so that's 7 times 2 to the power of 2n, which is what we would have got previously. This term actually here, just to keep the pattern going, is the same as 4 to the power of 0, okay, times 7. Okay, so you can see the way this is working out here, yeah? 4 to the power of 1. Here's a 4 to the power 4 squared. Here we have 4 cubed, all times 7. The 4 to the power is determined on the index that we're dealing with. Okay, so you can use iteration to solve these. Okay, iteration to solve these particular solutions, and you can also use what's known as the method of differences. Although the method of differences doesn't work when the coefficient of the previous term is not equal to 1. Okay, and we could do the same thing. We could do the same thing with our previous solution. Okay, it's a little bit trickier, I suppose, to do, but we could have a look at that. Okay, let's have a look at our previous one. The formula is a lot handier to use, but the formula requires that we understand where it comes from, which would mean that you'd have to look really at the previous video. So let's have a look at our previous example. So we have, so let's say we're going to, in this case, we're going to, once again, we're going to using iteration, iteration, right, we're going to consider, where is it gone? It's an is equal to 2 times an minus 1 plus 3, where a0 is equal to 5. And this gets a little bit messy here, yeah? Because we have a0 is equal to 5. Let's leave that alone for a moment, yeah? We have a1. a1 is equal to 2 times a0 plus 3, okay? And we know that a0 is equal to 5. a2 is equal to 2 times the previous one, which is 2 times a1, which is the same as 2 times a0 plus 3 plus 3. Okay? And what does that give us? Well, that gives us, what does that give us? That gives us 2 squared, okay? 2 squared a0 plus 2 times 3 plus 3. What about a3? A3 is going to be 2 times the previous one, so it's 2 times this. So it's 2 times 2 squared a0 plus 2 times 3 plus 3 plus 3, which gives us this plus 3 hanging out here, which gives us 2 cubed times